Hi guys, welcome back. This is day 10. This should be the last lesson of week 4 of NTI. At this time, you can see the date on my screen. It's April 9th. I'm very optimistic that hopefully this is the last video I have to film for you guys and that we will be back in school together in May. So I'm gonna stay optimistic about it. Let's get started. This is our last example, okay? We are going to talk about something called the average rate of change. You can see it in the problem. We want to find the average rate of change of two different pieces of work, a sculpture and a painting. So let's talk about average rate of change quickly. Average rate of change, which you will potentially see abbreviated. I am going to abbreviate it as AROC, just means slope, okay? You'll hear average rate of change all the time, as you move higher in math, potentially college classes that you take. It's just a fancy way of saying slope, okay? That's what slope does. That rise over run just measures the rate of change over time, right? When you say rise 1 over 2, that means that you increase by 1 every 2 years or 2 months or whatever. That's an average rate of change, okay? So the good news is that thinking about it as slope means that we can use, I'll make it like we're used to. We can just use that formula that we learned back in geometry, y2 minus y1 over x2 minus x1, okay? So average rate of change just means slope, and we can find it by doing rise over run, y2 minus y1 over x2 minus x1. So if we take a look at our problem, it says a museum purchased a painting and a sculpture in the same year. Their changing values are modeled. Find the average rate of change of the value of each work of art over 5 years. Which artwork's value is increasing more quickly, okay? So these things are getting more expensive the longer that you have them, okay? So think about it like a 30-year-old painting isn't going to be as much money as a 500-year-old painting. The older it gets, the more history that it has, the more money it's going to be worth, okay? So we're going to start with the painting value because it's really easy. They've given it to us on a graph, okay? So they've written out the coordinates for us. We can see them with our own 2 eyes. We've got our x1 and our y1, and we have our x2 and our y2. Okay, so what we're doing when we find the average rate of change is we're finding this line right here. Okay, so clearly the orange line is a little more curved than the dotted straight line, and so the average rate of change is just an approximation. It's an estimation about how it's averaging, it's increasing, okay, because it's not at a constant rate. Let's just go ahead and find those. So we know that the average rate of change can be found using the slope formula, y2 minus y1 over x2 minus x1. And so that's going to look like 64.4 minus 40 over 5 minus 0. That gives us 24.4 over 5, and then that simplifies to roughly 4.88. So that's it. That's as simple as it is if you have the 2 values as coordinates, okay? So if you can see them on a graph, this means that in year 1, the painting was worth $40,000, and that means that in year 5, the painting is worth $64,400. So what that means is that on average, it increased about $4,000 in value every year. Okay, that's what we just tracked. So it's not actually, because if you look in year 1, it looks like it's still about 40. Year 2, it's only about 40 something. So the average is an estimation, but at the end of 5 years, it approximately increased about $4,000 a year, okay? So that means that its average rate of change is about $4,880 in value per year. Okay, so now we're going to take a look at what it looks like when we are not given coordinates, when it's not that easy to just throw it into slope, okay? But before we do that, let's talk about what an ordered pair is and what that means and how we can use that to be more familiar, okay? So we know that an ordered pair is x comma y, okay? We know that that is the same thing as saying an input and an output. Okay? We also know, remember we talked about function machines at the beginning of the year. We know that y is the same thing as f of x. All of those things are an ordered pair, okay? Again, look at it on a graph. It's really easy to visualize. When I plug in 0, I get out 40. That's why my coordinate is 0, 40. Plug in 0, get out 40. Plug in 5, get out 64.4. So I have to make the coordinates myself. Here I'm given a function. I need to know what happens when I plug in 0 for x and when I plug in 5 for x. Because I want to know when the sculpture has 0 years, they've only had it, for a couple minutes, what was it worth? And then 5 years later, what has the value increased to? So because I don't have a graph to show me, I don't have ordered pairs, I have to make it myself. So I want to know what this function is when I plug in 0. So 1.075 times 0. So that means that when x equals 0, you could plug this into a calculator. Remember, calculate 84. Or Desmos or TI-84 software is available for you guys online. I plug this in and I'm going to get out 50. So I can say that when x equals 0, when I plug in 0 for x, my output is 50. Okay? And again, I can show you that on a calculator if you want. 50 times 1.075 to the 0. So then I go back. That's my first order pair. Now I want to know what the function spits out when I plug in 5 years. I want to use this function, and this function should look familiar to you. You have your initial value, which makes sense. When we bought the painting at 0 years, it was worth $50,000. Sorry, guys. This right here is my growth factor. It's bigger than 1. So we can see that it's getting bigger. It's accruing more money. And then my time is 5. I want to know what the sculpture is worth after 5 years. So I do that all. I can run that through a calculator. I'll just copy and paste this guy. And we get 71, and then we'll round 0.78. So we get, not 0 anymore. We plugged in 5. After 5 years, the painting is worth $71,780, whatever. You know what I mean. And so now that we've got our 2 ordered pairs, I'll change the color. Now that we've got 0, 50 and 5, 71.78. Now we have our y1s, y2s, our x1s, our x2s. And we can go ahead and do slope formula. So the only difference is here we were given the coordinates, and here we had to make them ourselves. Okay? So when I plug in 0, I get out 50. When I plug in 5, I get out 71.78. So now I get to do, 71.78 minus 50 over 5 minus 0. That gives me 31.78 over 5. Not 30, 21. Been a long day. And then that simplifies to 4.356, meaning that the sculpture has an average rate of change of $4,356 in value per year. So every year that this art gallery keeps this sculpture, it increases about almost $4,400 in value. It says which artwork's value is increasing more quickly. Well, if we look, the painting is accruing by $4,800 a year. The sculpture is about $43.5 a year. So I'm going to say that the painting is increasing faster. Okay? And that's all you got to do. So if you're not given coordinates, make them yourself. Plug in your 0 for your initial time, and then whatever the problem tells you to do. If it's 5 years later, then plug in 5. If it's 15 years later, plug in 15. But always start with 0 for your initial, and then do it again with whatever the new value is. Yeah, so again, like I said at the beginning, I hope that this is the last video that I have to make for you guys, and that I can go back and teach you guys in person, because I love doing that, and you guys are the best part of my day, and I miss you so much, and I can't wait to see you guys again, and I love you so much. And yeah, I hope you guys are doing good, staying active, keeping your brains active. Reach out to me if you need anything. It doesn't have to be math related. Yeah, I miss you guys. I love you so much. Hope you have a great rest.